So, have you ever noticed that a basic AI chatbot is incredibly smart, but also kind of entirely helpless? It's literally like a super genius brain sitting in a jar. Sure, it can write a beautiful poem about your SQL database, but if you ask it to actually log into that database, grab a customer's record, and send them an email, yeah, it completely freezes up. Today, we're looking at exactly how we solve that problem. How do we take that brain out of the jar, give it hands, give it memory, and give it the ability to actually act in the real world without the whole system just turning into complete chaos? Welcome to This Explainer. Today, we're diving straight into the fascinating world of LLM orchestration. We're going to look specifically at how modern frameworks and the Hugging Face ecosystem are transforming raw generative AI models into highly capable, multifaceted, and totally secure enterprise systems. Here's our quick roadmap for today. 1. The generative AI engine. 2. What is LLM orchestration? 3. Retrieval and external tools. 4. Building smart AI agents. And 5. Scaling with Hugging Face. Let's get into it. Starting with Section 1. The generative AI engine, the brain in the jar. To really get this, we need a first principles understanding of what sits at the very center of all these systems. At the core, obviously, we have the large language model, or LLM. Now, if you check out the Hugging Face Agents course, you'll see that at their core, these models are built primarily on the transformer architecture, usually decoders, that are trained on just massive, vast amounts of text. They might have billions of parameters, right? But their fundamental objective is actually surprisingly simple. Just predict the next token in a sequence. That's the whole gig. It's a brilliant text generator, but like our analogy from earlier, it's just an isolated brain. And that's the crucial point. LLMs are incredibly powerful, but they're entirely isolated. On their own, they have zero real-time memory. They can't learn new information instantly. They struggle with complex multi-step problems because their context window is strictly limited. And worst of all, they absolutely cannot fact-check themselves. If an LLM doesn't know the answer, it might just confidently hallucinate one. So we absolutely need a way to connect this isolated intelligence to the outside world. Which brings us nicely to Section 2. What is LLM orchestration? Basically, the nervous system. LLM orchestration is the framework that coordinates these massive models across heterogeneous computing environments. Think of it like the ultimate conductor of a symphony. The orchestrator doesn't actually play the instruments itself, right? Instead, it delegates. It manages the workflow. It handles prompt chaining, talks to external APIs, fetches data from vector databases, and it even manages memory across multiple conversations. So your AI actually remembers what you said 5 minutes ago. When you map this architecture out, the orchestration control plane sits right front and center. Notice how user requests do not go straight to the AI model anymore. They hit that control plane first. The plane mediates everything. It figures out exactly what context is needed, controls the execution flow, and manages state. The real genius here is that the execution logic is kept totally external to the model prompt. The LLM is treated merely as a safe, composable subsystem. It's literally just a tool that the orchestrator picks up when it needs some reasoning power. Now, this entire orchestration framework relies on 4 interdependent architectural pillars. First up, context retrieval, fetching the right documents before the AI even sees the prompt. Second, execution control, taking complex tasks, breaking them down into subtasks, and routing them intelligently. Third is state management, persisting the workflow so if a server suddenly crashes, your AI doesn't wake up with total amnesia. And fourth, observationality, tracking token usage and latency. And here's the kicker. These pillars are completely interlinked. If you weaken just one, say you've got spotty state management, the whole house of cards can come crashing down, making it impossible to recover from faults. Okay, Section 3, retrieval and external tools. How do we actually give this brain access to grounded, real-world knowledge? To solve this, we use a hybrid retrieval pipeline for RAG, Retrieval Augmented Generation. When a user asks a question, the system uses both standard keyword search like BM25 and dense semantic search. But pay really close attention to the security design here. Notice that the access control filter happens before the semantic search. If you do the semantic search first, those similarity scores alone could actually leak the existence of highly sensitive enterprise documents. By filtering first, unauthorized data never even enters the computation pipeline. That is zero trust principles in action, which is absolutely crucial. Just to put the sheer scale of this into perspective, in modern distributed AI systems, we can query 1 billion vectors in under 10 milliseconds using GPU-accelerated similarity search. It is just mind-bogglingly fast. And the results speak for themselves. By using RAG to ground the model with retrieved facts, accuracy improves by 10 to 30%. That drastically reduces those annoying hallucinations. Plus, that hybrid approach of combining keywords with semantics, that gives a 5 to 8% bump in F1 scores over basic models. It's a massive performance leap across the board. All right, moving to section 4, building smart AI agents. We have the knowledge, we have the orchestrator, now let's put it into action. A community developer on the Hugging Face forums actually shared a brilliant way to think about this. Instead of treating the LLM as an all-knowing encyclopedia, we build an AI agent. The agent acts as a logical conductor. It uses a custom middleware language to translate everyday human language directly into REST API actions. You literally just hand the agent your API documentation, and when a user asks for something, the agent figures out the right endpoint, formats the JSON perfectly, and fires off the request. This massively reduces your token costs and cuts the risk of the model hallucinating way, way down. When you adopt this agentic workflow, the practical applications are just incredibly cool. Imagine autonomous e-commerce agents that don't just, quote the return policy at you, but actually take your order number, hit the shipping API, check the status, and process the return themselves. Or think about your own internal workflows. Imagine internal tools where an employee types, "Hey, get last week's sales data and email the marketing team," and the agent seamlessly chains that workflow across Jira, your database, and Slack. Or lead generation bots, acting as invisible B2B salespeople that can pull an email straight from a chat and automatically save it to your CRM API. It's a total game changer. But of course, to make all of this actually work in production without collapsing under heavy traffic, you need serious infrastructure. Section 5, scaling with the Hugging Face ecosystem. Right at the infrastructure layer, Hugging Face provides text generation inference, or TGI. This is what you use to serve open source LLMs at massive scale. How does it do it? By packing in features like flash attention for serious memory efficiency, continuous batching so sudden traffic spikes don't totally bottleneck your system, and quantization for massive model compression. And, crucially for our orchestrator, it has built-in distributed tracing, so you can keep an eagle eye on token usage and latency across your entire microservice architecture. But what about writing the actual code for the agents? Well, the ecosystem gives you choices. For a long time, developers leaned on heavy frameworks like LangChain. They're incredibly comprehensive, sure, but they come with heavy abstraction layers. And as noted in the Mint Square breakdown, this often leads to a pretty steep learning curve and serious framework fatigue. So Hugging Face built something called Smolagents. The philosophy here is radical simplicity. You get one agent class, simple tools, and allows developers to just write Python code directly instead of having to memorize a dozen bespoke framework concepts. It makes prototyping these complex orchestrated systems so much faster. Now, let's look at a fascinating emerging concept here, the orchestration of experts. As your inference workloads grow, relying on a single, massive monolithic model for every little task gets way too expensive and inefficient. In a multi-model system, the orchestrator acts as a super smart router. It essentially interviews various specialized models offline during a training phase to learn exactly what their strengths are. Then, at runtime, when a user asks a question, the orchestrator dynamically routes that specific query to the optimal expert model. It's literally balancing cost, data privacy, and reasoning performance on the fly. To sum up this massive shift we're seeing across the industry, I want to share this really profound insight from the academic literature we've reviewed. Quote, "The transition from monolithic to distributed AI architectures mirrors the evolution of traditional software systems from mainframes to microservices." It really hits the nail on the head. We are officially moving past the era of the single giant brain in a jar, and we're entering the era of highly specialized, orchestrated microagents. So the big question I want to leave you with today is this. Are you ready to stop relying on a single AI brain and start conducting a multi-model symphony? By leaning into LLM orchestration, clever retrieval pipelines, and rock-solid ecosystems like Hugging Face, you can build systems that don't just talk, but actually act securely and intelligently in the real world. I really hope this explainer sheds some light on the mechanics of modern generative AI for you. Keep exploring, keep building, and we'll see you next time.